Hello and welcome to our lesson on solving equations with variables on both sides of the equation. As you can see in our first example, we have variables on terms with variables on both sides of the equation. So in order to solve this, what we need to do is get all the terms with variables on one side, all the terms without variables, in other words, constants on the other, and then we can go ahead and isolate the variable. So I have a negative 3x on the left, and there's no other constants or anything with it. So what I'm going to do is try and eliminate this 2x. And the inverse of the 2x is a negative 2x. Remember to keep your equation balanced. Whatever you do to one side, you need to do it to the other side. So a negative 3x and a negative 2x is a negative 5x. A 2x and negative 2x, that cancels to 0, and all I'm left with on the right is a positive 19. Now I'm going to isolate that x by dividing both sides by negative 5. So then I'm left with x is equal to negative 19 fifths, or if you want, you could write that as a mixed number, negative 3 and 4 fifths. All right, let's go ahead and look at another example. This time we have terms with variables and constants on both sides of the equation. So we're going to have to do a little more work to move them. So what I'm going to do, usually what I like to do in this case is keep the term with the variable with the larger positive value on the right, or actually that's where I'm moving my term with the variable, is wherever the larger term with the variable is. So in this case, 4.5y is larger than 2.5y. So I'm going to keep the 4.5y here. And that's because I want to end up with a positive y. So that allows me to keep a positive y. So I'm going to subtract 2.5y from both sides. And a 2.5 and negative 2.5 goes to 0. On the left I have 6 is equal to a positive 4.5 and negative 2.5y leaves me with 2y minus 1. Now I have a simple two-step equation, so I'm going to add 1 to both sides. On the left I have 7 equals 2y on the right. Now I go ahead and divide both sides by 2 to isolate that y, and y is equal to 7 halves, or you can write that as 3.5. All right, one more example. This one's even more complicated because we have distributive property on both sides. So really the easiest way to take care of this is go ahead and distribute first, and then take care of moving variables and constants to the opposite sides. So let's distribute first. So this is negative 2x, and then a negative 2 times a negative 5 is positive 10. Then we have 6 times 2 is 12. And this is 6 times a negative 1/2 x. So 6 times a half is 3x. And I keep the negative here. So notice a negative times a negative is a positive. Here a positive times a negative is our negative. Alright, so I have a negative 2x on the left and negative 3x on the right. Like I said, I'd like to keep the term with the larger coefficient for my variable on that side, so I end up with a positive. So negative 2x is actually larger than negative 3x. So I'm going to add 3x to both sides. So on the left, you could see a negative 2x and a positive 3x is x. And then a negative 3x and a positive 3x goes to 0, so I'm left with 12 on the right. Now I subtract 10 from both sides, and x is equal to 2. Notice I just had one x, so I didn't have to isolate any further, so that worked out nicely. Now for any of these, remember you can check your answer by substituting in the variable and the value into the original equation. So let's just do mental math. Let's put 2 in for x. So 2 minus 3 is negative 3. Negative 3 times negative 2 is positive 6. So the left-hand expression would be positive 6. On the right-hand side, we have put in 2. For x, 1/2 times 2 is 1. So then in the parentheses, 2 minus 1 is 1 times 6 is 6. So both cases, 6 would equal 6, so x equals to 2 works out perfectly. All right, so go ahead and try this on your own. All right, so you should have gotten x equals negative 3. And one more on your own. All right, and this time z is equal to 3. All right, that'll do it for this lesson.